So we're in section 1.2. And we're measuring length. So just a quick reminder about the number line. Because we're going to talk about the number line a little bit today. So on a number line, if you're moving to the left, you're going in the negative direction. If you're moving to the right, you're going in the positive direction. If you start at 0 and go to the left, you're going to the negative numbers. Start at 0 and go to the right, you're going to the positive numbers. So I just wanted to kind of quickly remind us about the number line and how it works, because we're going to be talking about it a little bit. So the first thing that we're going to talk about today is the length of a segment. And a big part of what we do here at the beginning of geometry is, like I said the other day, we use a lot of words that are everyday words, but we use them in very specific ways. So we need to be very precise about what we're talking about when we use these words. At first, our ideas are going to match up with how we think of these things every day. Sometimes the everyday words don't exactly match up with the way we use the words in math. We're trying to be precise with what we're doing. So if we're talking about the length of a segment, how do you think we figure out the length of a segment? What do we do? Measure it. We have to measure it somehow. And if I have a segment up here and I measure it in inches, and then I turn around and measure my segment in centimeters, does that change the length of the segment? No. What's changing?
Unit.
Just the unit, the number. But the length itself isn't changing. So I could pick any unit I wanted. I could say the distance between those two little marks was 1 Beamer unit. And I can measure things in Beamer units. But if I measure this table and say it's 83 Beamer units, it's not different than saying it's a 6-foot table. It's just the number that I give to it. So I can pick any unit to measure something, but it doesn't change the length. So the length is the idea of the length is something that it has to do with how big the thing is. The numbers, we can put different numbers to it, but the length doesn't change. So let's define the length of a segment, and then we'll draw a picture to tell us what that means. If the length of the segment matches up with how we think of it, it's just how we go about defining it seems a little complicated. So we have 2 points, A and B, on a number line. And small a and small b are the coordinates of the points. And all that means is small a and small b are the number on the number line where these points are sitting. So this is just the numbers on the number line. So in parentheses, I'm going to put numbers. A and B are just numbers. So A and B are if we put the point A above a point on the number line, small a is that number that's there where it's sitting. We're going to say the length of segment AB. The other way we say length is the measure. The measure of segment AB. Is, and our notation, our symbol for length is the measure. The small m means measure of segment AB, or we can write just the 2 points without the bar over them. That's the length of the segment. And this equals the absolute value of b minus a, or the absolute value of a minus b. We'll draw a picture to talk about what this is telling us in just a second. So why do you think we have these absolute values here? What does absolute value do to a number? Absolute value of a positive number is positive. Absolute value of a negative number is positive. So the absolute value, make sure it's always positive. Because can we have a negative length? Can we measure something and say it's negative 5 inches long? No. So the length is just talking about how long it is. It doesn't have anything to do with the direction. So when we're talking about length, we're always talking about a positive number. So we always have a positive number for length. So that's why we have these absolute values here. So we'll do an example here in just a second. But remember that this M in front of our segment AB means measure, or if I have AB without the segment bar over the top, that means the length. So let's draw a picture. Here's my segment, or here's my number line. And we're going to put a couple points on here. We'll say this is at 0. And point A is here at 5. And point B is here at negative 3. So I have point A here at 5 and point B here at negative 3. And we want to find the length of segment AB. So for this example, we have 3 ways we can do it. If your spaces, if your points are close together, we can just count. We can count from one point to the other. So I could count 1, 2, 3, 4, 5, 6, 7, 8. I can just count 8 spaces. So that's one way I could do it, is count spaces. And that tells us that the length of AB equals 8. And it doesn't matter which direction I count, there are 8 spaces between these 2 points. But if we had really big numbers, say A was at 732 and B was at negative 1,285, it would be kind of hard to count those spaces. So let's use our equation here. Our equation tells us that AB, and I'll use our other symbol, the measure of AB is the absolute value of negative 3 minus 5. Negative 3 minus 5 is what? So if I go 3 spaces to the left and 5 more spaces to the left, negative 8. There we go. So I go 3 spaces to the left and 5 more spaces to the left. I'm 8 spaces to the left. I'm at negative 8, and the absolute value of negative 8 is 8. And I can put the numbers in the other order also. So I could say AB, the length of segment AB, is the absolute value of 5 minus negative 3.
Why is that what it's going to be?
Just to make sure I have just to remind me I have a minus and then a negative. I could put minus minus. That would be fine.
So it will be positive or?
Right, so if I have a minus, what happens to that? Turns to a positive. So I get a positive 8, and the absolute value of positive 8 is 8 again. So no matter how I do it, I get a distance of 8 whatever our units are here on our number line. 8 spaces between the 2 points. So that's all that length, that's all this definition is telling us. How far is it between the endpoints of my segment? Just like we would think. We measure it somehow. The number line, we could think of the number line as our ruler. All right, any questions on measuring lengths of segments? So now we know how to measure lengths of segments. We're going to compare them. And to compare them, we need a new word. Congruent. Anybody have an idea about what congruent means? Yeah. The same. And when we say the same, what's the same? Two numbers. So we're talking about a shape. If two shapes are congruent, they're the same. Different size? Same shape and same size. So we're going to say for congruent, and I'm going to use exactly. Exactly the same size and shape. And we'll work a little more on making this definition a little more precise, what we mean by exactly the same size and shape, a little later. But for now, this will be our kind of our working definition of congruent. So congruent means exactly the same size and shape. And Michael, you said something about the number. So we're going to talk about that in just a second. Our symbol for congruent is an equal sign with a little squiggle over it. For congruent, this symbol means congruent. So if I wrote this, what this is, if I would to read this, to put it in a sentence, I would say segment XY is congruent to segment YZ. That's how I would read this. Segment XY is congruent to segment YZ.
Hey, so one question.
Yes.
If we have an equal sign with a squiggle over it, doesn't we also have a three-line equal sign? Just thinking of that three-line.
The 3-line equal sign means usually means defined or is identical to. So it's a little bit different. It's a little bit different. So this is our symbol for congruent, and we read it this way. And to show congruent on figures, tick marks show congruent segments. And I'll draw a picture to show what that means. So if I drew a figure here, it looks like so. A rectangle with a triangle on the side. And if I put a mark here and a mark here, that means that those two sides are congruent. The tick marks on the sides mean that this side would be congruent to this side. If I put 2 tick marks here and 2 tick marks there, that means those two sides are congruent. If I put 3 here and 3 there, that means the these two sides of this triangle are congruent.
Sorry, why are those going?
Because if I had something like, say I had say this is supposed to be a square. If I did this, That means all 4 of those sides are the same, are congruent.
So you're basically just numbering them without really...
Sort of numbering them without numbering them. It's just a way to compare them, to say these 2, because they each have 3 marks on them, these 2 are congruent. These 2, because they each have 2 marks, are congruent. So if I had a bunch of segments with 2 marks on them, all of those would be congruent. Okay? So this is how we show on figures, this is how we show that things are congruent with the marks. All right, so this leads us, now we have an idea about measuring length. We know what congruent means. Now we're going to talk about a couple of postulates. So what did we say a postulate was? What do we mean when we say we have a postulate? What is a postulate? Something that's true, that we believe, that we accept as true, but we can't prove it. So a postulate is something we accept as true without proof. So our first postulate is the segment congruence postulate. So we're interested in comparing segments. So how do you think, based on what we've talked about already, how would we show that 2 segments are congruent? If 2 segments are congruent, what are we saying about them? Same size and shape. And from what we talked about at the beginning, we're measuring segments, we're talking about their length. What would that tell us about those segments if they're the same size and shape? They would have the same length. That's our postulate. To compare segments, we talk about their length. So congruent segments have the same length. So I'm going to write this out in a little more words. If 2 segments have the same length, then they are congruent. And I'm just going to use the symbol here. Then they are congruent. If they have the same length, they are congruent, the same size and shape. And this also works in the other direction. If 2 segments are congruent, then they have the same length. And we'll talk a little bit more in chapter 2 about why we put this in both orders, why we put then they have the same length. So we'll talk about why we put the postulate in the first order and then turn the order around. And it has a special name, and it has to do with how we use logic. So the way we figure out if segments are congruent is if they have the same length. And if they do have the same length, we know that they are congruent. So this pretty much lines up with the way we think about this every day. That to compare 2 segments, we're comparing their lengths. All right, any questions about the segments congruence postulate? All right, we have one last postulate. The segment addition postulate. So we have talked about how we measure segments, how we decide if they're congruent, how we compare them. The segment addition postulate tells us how we put them together. So let me write it out. It sounds more complicated than it really is. So if point R is between point P and Q on a number line. Just random, these are points, just random points. So point R is between point P and Q on a number line. Then the length of segment PR plus the length of segment RQ equals the length of segment PQ. So this sounds kind of complicated, but it's really not. Let's draw a picture. So here's my number line. This is telling us that R, point R, is between point P and Q. So here's point P, and here's point Q. So let me draw, I'll show what lengths we're talking about here. So this distance is PR. This distance is RQ. This whole distance is PQ. So all the segment addition postulate is telling us is that if we have two shorter segments, we can put them together and add their lengths to get the length of the long segment. So it just tells us we can add two shorter segments to get a longer segment. That's all it's telling us to do. We can put two shorter segments together to get a longer segment. And to figure out their length, we just add the lengths of the shorter segments. That's really all it's telling us. So it's just like me saying, here are my points, PR and Q. I put the ruler there. If I add this length from P to R and this length from R to Q, that tells me the length of the ruler because P and Q are at the end of the ruler. So I can just add those pieces together. And it doesn't matter where R is between those 2 points. I can just add the two pieces to get the bigger piece. Adding two smaller pieces to get a bigger piece. That's all it's telling us. Questions on that? So again, pretty much lines up with the way we think about putting lengths together. All right.